Hello again. Today we're going to be talking about problem solving that requires integration. So let's get started. For example, we have the marginal profit from producing X toys per week is given by the function P prime of X is 12 minus 0.05X dollars per toy. If the factory produces no toys, they incur a loss of $540 per week. So I need to find the profit function. I've got the derivative of the profit function, but I need the profit function. I also want to know what is the maximum profit and when does it occur. So there's my derivative function. That's the derivative of the profit function. So to find the profit function, I need to find the antiderivative. The antiderivative of that function is 12x minus 0.025x squared plus a constant. Now, in order to figure out that constant, it's important to know that when 0 toys are produced, the profit is a loss of 540. So that's what my function is going to look like when I set x equal to 0 and the profit equal to negative 540. And all that means is that my constant of integration is negative 540. It's good to know that because now I know my entire profit function, which is 12x minus 0.025x squared minus 540. All right. So to figure out the maximum profit, I would need to find the derivative and set it equal to 0, just like I would with any other maximization problem. I already have the derivative. I was given the derivative in the question, so if I set that equal to 0, then I get that x will equal 12 over 0.05, which is 240. And if I plug that into my profit function to get the profit when I make 240 toys, I get an answer of 900. So what that means is there's a maximum profit of $900 if I make 240 toys. All right, a second example. In 2010, the population of Newtown was 200,000. Since 2010, people have been moving into Newtown at a rate of f prime equals 120 minus 4e to the 0.12 t. And that's in thousands of people per year. Since 2010, people have been moving out of Newtown at the rate of g prime equals 90 minus 3 times e to the 0.09 t, thousands of people per year. So I need to find the population function, and I need to know when Newtown's population will be maximized and what that population will be. So the change in population is a positive amount of f prime and a negative amount of g prime because the rate of people moving in is that f prime function, and the rate of people moving out is that g prime function. So one has a positive effect and one has a negative effect on the population. So what I'm going to do is I'm going to find the antiderivative of that to get the population function. So that's going to be 120t minus 4e to the 0.12t over 0.12 minus 90t plus 3e to the 0.09t over 0.09 plus my constant of integration, which I still need to figure out. All right, I simplify all of that just to make it look nicer and not have decimals within fractions. And so now I can find my constant of integration. I know that at time or in the year 2010, the population was 200,000. And since population is expressed in thousands of people, I'm going to plug in 0, which is the time from 2010, and I'm going to set the p-value to 200, which represents 200,000 people. So what happens is I get negative 100 over 3 plus 100 over 3 plus c equals 200. And so that means my constant of integration is 200. So now I have my population function. I can replace c with 200, and that is my population function. All right, so the next part is going to be when will the population be maximized and what will the population be? So there's my population function. I've rewritten it at the top. If I want to know when it's maximized, I start with the derivative that I had on the previous slide. And that's what I would have. And I set it equal to 0. All right, and so when I do that, I can use technology to do that. I can do it by hand, but I would get an answer of 21.034. So that is the time when population will be maximized. And since 0 represents the year 2010, then t equals 21.034 would be 21.034 years later, which is the year 2031. The population at that time is just going to be my population function with that value of t plugged in, and that gives me 636. Now, since population is expressed in thousands of people, then the population will be 636,000 after the year 2031. All right, so that is how to solve problems using integration. Just with a couple of examples. We'll go through more examples later. If you have any questions about that, please let me know, and I will see you tomorrow.